Okay, so we're going to look at core homework 6.4.1 methods and learning. It says Erica works in the soda bottling factory. As bottles pass her on the conveyor belt, she puts caps on them. Unfortunately, Erica sometimes breaks a bottle before she can cap it. Ooh, doesn't sound too good. She gets paid 4 cents for each bottle she successfully caps. So for each bottle, that word each again is a sort of like a slope word. So she gets 0.04, because that's 4 cents, not $4, times every one she caps. So whenever she caps one, she makes money. She makes 0.04. All right, that's something to recognize. But her boss deducts. Does that sound good or bad? That sounds bad, right? It's like her boss takes 2 cents from her pay for each bottle she breaks. So if she breaks a bottle, she gets negative 0.02 for every one that she breaks. So that's how we're going to write that little expression. And the ability to write those expressions, that's the tricky part. Every time she caps one, she gets 4 cents. But every time she breaks one, she loses 2 cents. So 2 cents times the number she breaks, and 4 cents times the number she caps. Unfortunately, Erica's having a bad morning. 15 bottles have come her way. So what we could say for sure is that the number that she caps plus the number that she breaks together has to equal 15. After all, she either breaks them or she caps them. So the ones that she caps plus the ones that she breaks together, they have to equal 15, because that's how many she's seen altogether. But she has been breaking some and has only earned 6 cents today. Okay, what we could say is that this, 4 cents for every one she caps plus 2 cents that she loses for every one she breaks makes a total of 6 cents. So here's our third equation is going to be this. It's going to be that expression. Excuse me. It's going to be this plus this is equal to 0.06, which is 6 cents. There we go. Because she gets 4 cents for every one she caps, she loses 2 cents for every one she breaks, and in total, altogether, she gets 6 cents. So we can add these two expressions together to get the total, and there we have it. So how many bottles has she capped and how many has she broken? Okay, the first thing we're going to do is write the system of equations. And as usual, I wrote my equations right in the middle of the written area of the word problem, because I think it's easiest to recognize them right in the middle of the context. So I take my clues and I put my clues together. All right. So now we need to solve the system using two different methods, substitution and elimination. Okay. Then we're going to demonstrate that they both get the same thing. So first we'll do substitution. In order to do substitution, we have to get a variable alone. So I'm going to start with equation 1 for substitution. And the first thing I'm going to do is I'll get C alone. So I'll subtract B from both sides. Cap locks. No, I'm not just screaming at you. I'm not saying that this is extraordinarily important. I'm just accidentally hitting cap locks. Let's try that again. So, oh, there it is. Okay, subtract B from both sides. And that will get C is equal to negative B plus 15. All right, and then the word both is usually not spelled that way. It's more frequently spelled B-O-T-H. Okay, and then we have our second equation, which is going to go right here. So then what we're going to do is we're going to sub in negative B plus 15 every time we see a C. So what I'll do now is I'll rewrite this equation. I'll get rid of the C, and instead I will put this in parentheses where the C was. Okay. So now I've got to distribute the 0.04. And that's going to get me 0.04 times negative b is negative 0.04 b plus 0.04 times 15 is 0.60. You can look it up if you're not completely convinced. Plus negative 0.02b is equal to 0.06. Okay, now what I got to do, I'm going to combine like terms. Because I have the negative 0.04b and the negative 0.02b, I'll put those together and I'll get negative 0.06b plus 0.60 is equal to 0.06. I'll have to subtract this 0.60 to get it alone, so I'll subtract 0.60 from both sides, of course, and that will get me negative 0.06b is equal to negative 0.54, because it's this negative, when I subtract 0.60 from 0.06, it becomes negative 0.54 because I'm subtracting a larger amount from a greater amount. By the way, always feel free to check Desmos with your answers. It's very useful. Okay, so negative 0.06b is equal to negative 0.54, so I'll, of course, if I want to find b, I'll divide by negative 0.06. And what that gets me is b is equal to negative 0.54 divided by negative 0.06 is 9. So she has broken 9 bottles today. And if she capped C plus B equals 15, and B equals 9, then clearly C is equal to 6. So our substitution solution, the number she capped plus the number she broke is 6, 9. Now we'll try elimination method to find the same thing. So we'll take the same original 2 equations, but we'll do elimination instead. So if I look at these two, I can eliminate the C or the B. I'm going to choose to eliminate the B. And what I need to do is get the opposite of this. So if I have negative 0.02, then I need positive 0.02. So I'm going to take this entire equation here. I'm going to multiply it by 0.02. Okay, 0.02 times, because what I want to do, of course, is make the B's disappear. So when I distribute that, it'll get me my new equation. So 0.02 times C is 0.02C plus 0.02 times B is 0.02B is equal to 0.02 times 15 is 0.30. Okay, so I've got this equation here. I got that by multiplying here. Okay, and what I'm going to do is I'm going to do elimination with this equation. So put this equation down below. It's nice to think of it as an addition problem, and it's also wise, as Paulina Rivera showed me, to underline to show that we're adding here. Okay. So what should happen is that the B's should eliminate. So let's take a look. 0.02C plus 0.04C is 0.06C. Nice. Plus 0.02 and negative 0.02, of course, will make 0. And that will equal 30 plus 6 is 0.36. So now we'll divide by 0.6. Or 0.06. And that will get me C is equal to 6. All right, and then we can just plug that back in. We know that one of our original equations is that C plus B equals 15. So then if C is 6, then B must be 9, because 6 plus 9 equals 15. So our elimination solution is, again, 6, 9. All right, so did the, both get the same solution? They did, which is a really big deal. That's a good way of knowing that you've done something right. If you do it 2 different ways and get the same answer, you know you've done it right almost 99% of the time. Is one method more efficient than the other? Well, one way to look at that is just to see which one took less work. And I would say, yeah, the elimination method took substantially less work. The math was easier, there were fewer steps. It got us to our answer. They both got us the same answer, but the elimination method had fewer steps. So I'll be like, yes, the elimination method took fewer steps and the steps were easier. So, I mean, if you want to talk about the definition of efficient, efficient is less work and easier work. If it's less work and easier work, it is more efficient. So yeah, we would say the elimination method was more efficient for this problem. Nice.